Okay, so good afternoon and good morning, everybody. Thank you for joining today's webinar. We still have a few people are connecting, so we are waiting 1 minute more. In the meantime, please confirm you can all see and listen to us properly. Great, thanks for confirming. Okay. Great, so let's officially kickstart this webinar. Again, good afternoon and good morning, wherever you're based, to everybody. My name is Sara Pittonet. I am the coordinator of the Blue Cloud 2026 initiative, which is the initiative that is bringing to you this webinar, which is part of a series of webinars under the umbrella of the Blue Cloud Training Academy. Today, the focus of the webinar is applying FAIR principles across the ocean data management value chain. This is the third of a series of activities dedicated to addressing the FAIR principles for the marine data management communities. I'll give you a very short introduction of the Blue Cloud initiative to set the scene and let you understand why we are here today. So Blue Cloud is a project funded by the European Commission under the Horizon Europe program. It started 1 year ago, well, almost 2 actually, in January 2023, and is dedicated to building a federated European ecosystem for fair and open access services and tools to facilitate research, in particularly in the marine, seas and coastal topics. The project works and is delivered under the umbrella of the European Open Science program that you'll hear a little bit more about that in a while. And as the objective of bringing together solutions, data sets, data products, and services for developing a thematic marine open science environment. We call them nodes in the European jargon, to serve the need of the broader research community working in marine and ocean research. So the project didn't really start in 2023, since it relies on work that was kickstarted many years ago, and in particular started from 2019. So it's a continuation, and it's building a platform where different services are being pulled together under the open science umbrella to respond to broader objectives within the different European but also global policies in support of ocean knowledge, starting from the EU Green Deal down to the European Mission Ocean agenda and the Destination Earth directive. So, as I said, the Blue Cloud initiative and the partners involved are working to offer a collaborative environment where researchers can access and analyze data sets, leveraging on analytic resources, computational resources, storage resources, all in a same environment. The purpose is to allow and bring together the marine community to engage in transparent and reproducible science with the objectives of facilitating sharing of not just solutions, but actual methodologies. The Blue Cloud project is working within, let's say, two major programs under the European Commission. One is the European Open Science Cloud that I mentioned before, and another one is the Digital Twin of the Ocean program. So with respect to the European Open Science Cloud, for those who might not know it, the European Commission is pulling together efforts to bring together a federation done via a number of entities that they call nodes, that all together should serve as a system of systems to offer with access, let's say, from one place, but distributed across countries, institutes, and entities in Europe, facilities for research, from services available in data repositories, in research infrastructures, at research centers. So this federation is taking place, is really just born, I would say. So of course the system lies on years of collaboration within Europe, but is now taking shape as an actual European Commission service, and is bringing together institutional, regional, national entities to collaborate to offer services in a federated and shared way. All this also goes in parallel with another important initiative that the European Commission is driving, which is the European Digital Twin of the Ocean program. And in particular, there are a few projects that are building some technical infrastructures to make this possible. They are the EDITO project, so you might hear about them if not already, which are also driving efforts from other as well initiatives of projects with the aim to facilitate the development of applications for creating digital twins of our oceans. So Blue Cloud is contributing to both these efforts. And this is the framework where you should also take the webinar of today. Blue Cloud is brought to you by 40 partners. So those in the circles are the coordinating entities, and myself and the colleagues today are from Trust IT. We act as project coordinator, but you'll see that many others are supporting this effort all together. And this is the community that is showcased interest for this last webinar of this series. So we had 90 registrations from many institutes. You'll see them listed here today, just to give you an idea of who you could liaise to after today to continue the discussion around topics that relate to the FAIR principles. So, we had interest from all over the world. Of course, European members are the majority. And that's the agenda for today. So we have 4 speakers that will all tackle aspects that relate to FAIR data management practices, touching different moments of the data value chain, with reference, of course, to marine and ocean data, from the moment of gathering them up to their usage in shared and open science context. We will start with Lucie Coquepot from OceanoVox. She will present a case of application of the FAIR principles in ocean and water quality monitoring sensors. Then we'll move to Delphine Dobler from EuroArgo, and she will explain how EuroArgo is adopting fairness in their data system. Then we'll have Joanna Beya from Leeds. She will give a presentation on data fairness within Eurobis data from immunobiology. And last but not least, Justin Buck from the National Oceanographic Centre in the UK will give a presentation about some examples of complex citations of data, reproducible research and credit for originators. Tackling the challenges in ensuring fairness at the last level when data needs to be cited for their use. Feel free to use the question and answer chat to ask any questions during the presentations. We have a dedicated discussion time at the end, but we will take questions also for our speakers during the presentation, and we will also have a short interactive moment more towards the closure. With that, I finish my introduction, and I give the floor to Lucie for the first presentation of today.
Thank you very much. Just let me share my screen. There. Wonderful. Can you see my screen correctly?
Yes.
Perfect. Well, thank you for this introduction. My name is Lucie Cocampo. I work at Ifremer France. My job is to coordinate ocean observing systems, and I've been invited here to give a presentation about a project I developed with a company, Oceanovox, in which the FAIR principles played a major role. And I hope that through this personal experience, we will be able to provide you some elements for more general reflection on the FAIR principles. So this project, Oceanovox and Ifremer, was basically an answer to a call for expression of interest launched by my academic institution, Ifremer, and a company, Kineis. The aim of this call for project was to boost the development of marine and maritime services using the Internet of Things via a constellation of nanosatellites. Actually, Kineis is running a constellation of nanosatellites. So the total budget of the project was 350,000 euros, and the duration was 2 years, 24 months. Basically, we had two main partners, Ifremer and Oceanovox, and Kineis, and also the CNES, the satellite institution, were supporting this project. So the aim of our project was to co-develop an in-situ metocean data collection solution using, one, a network of vessels of opportunity, basically sailing boats, and the Kineis technology to make the collection of high-quality marine scientific data affordable and easy to implement. So, how it started? When the subject came to my office, I said, oh no, not another startup wanting to make money out of the collection of the data in the ocean. I tend to receive a lot of emails from companies trying to sell me data. And basically, when a company X comes to my office, they say, oh, look, we produce data in the format of our choice. That's what we're developing. We have a strong idea in mind. So basically, it's not interoperable. And we want to sell you the data we acquire, but just to you. So the data are not findable. It's just a one-to-one interaction. Look at my data. You can have it, but that's not findable for the community. And then the company says, you need to keep the data to yourself. This is, our business agreement. We sell you the data, you keep it to yourself. So the data is not accessible to the community. And then they usually say, once you've done your wonderful work, you've produced your research, we want recognition from that. So they just start discussing royalties or publicities and stuff. And that's not very easy then to reuse the data because we've agreed, they want us to agree on a specific agreement about the recognition of the data and the product realized through them. So I was not very optimistic when Oceanovox came to my office, but we discussed a lot, and they said, okay, we understood the philosophy of your community, so let's make an agreement and decide that the data and the metadata we will use will be developed according to the vocabularies of your community. And they start interacting with Emonet, specifically, I think it was the ingestion team. So that was nice. That was the first time that a company said, okay, we will meet your partners and we will see how it works, and we are okay to use the same vocabulary as your community. And then they say, okay, so we understand that we want to help you in order to monitor the ocean, to document the climate change. And I think this is a nice mission. So the data we will acquire together will be free of charge for the scientific use. And then along our discussions, they said that, okay, maybe the data we will produce in common needs to be available through the main data aggregator, the reference databases, and that's okay for us. And then they decided that all the data and the production, the scientific production we will produce together will be accessible through a clear data usage license, basically Creative Commons. So this time I'd say, okay, let's give it a try. Let's try to have a project together, because I think, according to me, but this is open to discussion, we were in a very fair, principle, compatible context. And oh yeah, that's one detail. Months later, when I look at the company official description, you know, you have all those official documents when you need to describe your company. I found it quite funny that Oceanovox was stating that their company was specializing in environmental data acquisition, building consistent network of ocean and climate sensors, drawing on disruptive technology with data made available in interoperable format and qualified according to the GOES Global Ocean Observing System standards. I thought that maybe, in a way, our interaction was influencing the way they were describing themselves. And yes, Oceanovox is deploying a low-carbon alternative in regions of the world where reliable, accurate information is most urgently needed to address the climate change. Just that's enough for the publicity. Let's go back to the project. You know, co-develop an in-situ metocean data collection solution using vessels of opportunity and another satellites. So basically, the project was this. One part was to design a system collecting the ocean data, and then the data would go to a cloud, and then there will be some development of services out of this data, and also a nice web-based interface and phone-based also, just to access to the data. So Ifremer was mostly involved in this part, the requirements, acting like as an expert for the data, for the system solution and the process of acquiring the data. And Oceanovox was dealing with the other part, all the downstream services about with the data. So I wanted to share with you today some lucky findings I had during this project. And the first one was that we worked with a Fab Lab with this project. We did a subcontract with a Fab Lab from the University of Western Brittany, UBO. And I think that was really good to help us to share the same language and to be more innovative in our solutions. We had to develop a new system. So we had a hackathon with some students, with the society, with enterprises, and with people from the academic world. We developed a first prototype, which was made of plumbing material. And we were also able to discuss through all the possibilities for patenting, from patenting to open access development. And we were very happy to have some information about the Creative Commons licenses. Then a second finding that I found interesting, it was to work with a sensor developer with a very with interest on the FAIR principles. By chance, we chose an RBR sensor for our system, and we found that the company was really willing to share some documentation, some even software, piece of software with us, and was really accessible for us to ask questions. So along the project, the relationship from a supplier interaction to a partner interaction. And that really helped our dynamic. And of course, at the beginning of the project, we asked them if they wanted to be a partner, and they had no time for that. They said no. But because we were developing some interesting stuff, thanks to their open access material, they got hooked. They got really interested in what we were doing. So even for this side partner, our project was really creating an added value. And it was really interesting to note that, I think. And that's a small picture of one turning point in our relationship when the CEO of RBR, Mr. Johnson, was invited to Ifremer, and we got the opportunity to show him some results, and then he got really interested in the project. And another interesting point of our project was the link to society. Through a series of fortunate events, we came in contact with the organizers of around the world sailing race, the Vendée Globe, happening right now. And we got the opportunity to present our development, our ongoing process. It was not even results at this stage to all the sailors doing this race. And some of them were seduced by the initiative and agreed to test our solution on board during the race. So we got the opportunity to put 2 prototypes into 2 IMOCA sailing boats doing the race, and for all the sailing community, having our system tested in very rough condition, because the race is going all over the world, was really an interesting proof of concept, and we were quite enthusiastic with that. So the last lucky finding I found in this project was not only to be linked to society through a lot of communication opportunities, but also to become an ambassador, in a way, of FAIR principles. Because at the end, not only have we applied the FAIR principles to the purpose of our project, to give open access fair marine data, but we've tried to apply those principles to the project in itself through great attention to common vocabulary. We came from very different backgrounds in this project, so we had to pay attention to the vocabulary that we're using, because words could have different meanings, you know. We also put all the information about the project on the cloud, so everybody could have a direct, instant access to all the documentation and to have an instant, clear vision of what was going on in other parts of the project. We were also putting a lot of attention to our communication and also to our achievement, to promote them through the project, to celebrate them. And we try to build a transparent governance, and also to have an easy to access team to be there for each other on a regular basis. So yeah, I think that's all for my presentation. I thank you very much, and yeah, can't wait to interact with you and see how this could fit into the series of presentations today.
Thanks a lot, Lucy. Very, very interesting. So I now invite our second speaker, Delphine Dobler from EuroArgo.
Good afternoon, everyone. Can you see my screen?
Yes.
Great. So, good afternoon. My name is Delphine Dobler, and I am data scientist for the EuroArgo ERIC. I will present you what is fairness within the Argo data system and what we do toward fairness improvements at our scale. Before speaking of fairness, and because some of you may not be aware of what EuroArgo is about, let me briefly present you the ERIC and the Argo network. So the Argo network purpose is to study the ocean properties for climate, as the ocean is the primary regulator of the climate, with 93% of the heat excess and 25% of anthropogenic carbon stored in the ocean. Floats in the Argo in situ array carry sensors that measure temperature and salinity for its core mission, but also biogeochemical parameters such as dissolved oxygen, nitrate, pH, backscattering, irradiance, and chlorophyll A. Down to 2,000 meter depths for the initial core mission, and down to 6,000 meter depths for its deep mission. It is global, also reaching high latitudes that have specific technological challenges and measuring marginal seas properties. Thanks to these observations, our Argo array helps assessing the climate change, such as a decrease in the ocean heat content and global sea level rise, the exchanges of energy between the atmosphere and the ocean, the operational climate and the ocean forecast, the ocean health, including the ocean acidification, the oxygenation, primary production, and so on. We have mainly two groups of users, which are the operational oceanography and the scientific research. Argo array represents a fleet of about 4,000 autonomous floats. The first test and deployment began in the year 2000, and the operational array as defined in the original design was reached in the mid-2000s. The map on the bottom left shows you the location of the floats as of January 2024, with a color per float's nationality. And the photo on the bottom right illustrates an Argo float deployment from a ship. So let me show you the operational life cycle of a float within the Argo program, and more specifically at the EuroArgo ERIC. First, there is procurement and delivery, which implies the institute, the rig itself, and the manufacturers. At the EuroArgo ERIC, we perform acceptance tests in the Ifremer pool and return back faulty floats if necessary. Then floats are shipped to institutes and deployed upon opportunity vessels or ship. Data are then processed by the data assembly centers in the rig case that are located at the Odyssey and Ifremer, and gathered within the global data assembly centers. We monitor the array for failures, such as technical failures or within the transmitted sensor data, with return loop to manufacturer, or even stop deployment of a specific model or serial number service if ever necessary. At the end of the life of a float, we perform recovery whenever possible and refurbishment for new deployment. Here, I want to emphasize that all the important information from all these steps here must be kept within the Argo embedded metadata. The metadata field content is enriched with each life step, and the granularity of what and how information should be embedded is continuously improved within the Argo International Program. Although each step is described in documented procedures. If I show you all these details, this is because with this metadata timeline here, you can see the first steps of where fair data starts in the system. And finally, this is a downstream distribution of the Argo data. So on top, this is the dataset architecture with data in its metadata, raw and delayed mode, indexes, and so on. I've skipped more detailed presentation of our data system for the sake of time, but you have here a really general overview. So this data, they are accessible through direct access, as shown on the left, and with the help of a synchronization service if necessary. They are accessible through daily copies on S3 bucket for better access performances, which is quite new. They are accessible through monthly copies, which helps in referencing a scientific paper, for instance, which is of utmost importance for the reproducibility of results of a scientific analysis. This is also accessible through copies and additional quality controls on the Copernicus Marine Service, EMODNet, CDataNet, Watershed Database, and other Federation data services. This part is circled by a dashed line because it is outside our ERIC scope per se. Finally, the data are accessible through a series of services, such as the fake monitoring data selection tool that includes the Swagger API and AirDAP threads and Sparkle point. The control vocabulary for metadata is exposed on the web on the NERC vocabulary server. And finally, there is a Python library RGOP, which allows to select which access points and the level of information depending on the user's need. These access are used and enhanced by several EOS-created projects, such as EnviFair, EnviHubNext, Ferries, and BookWalk 2026. So I've spent the last 5 minutes to explain you on the Argo system because, well, in my opinion, we can't speak of fairness tools for evaluation without speaking of the object that is being evaluated. So let me go through some open doors. Fairness means, findable, accessible, interoperable, and reusable. And this is a necessary step toward open science. This concept of fairness was officially defined in March 2016, but FAIR was here before the concept was defined. In our design, also original design. This concept is multifaceted, and it is something that can apply throughout the system in all layers at all levels. The web exposition of it being one of the final downstream showcase. First, let's ask question for who, what, or said which entity the system should be fair. This is a three-sided coin with connection between the humans, the servers, and the web applications or browser. And never of them entities should be disregarded. In particular, this implies for the humans the existence of an accessible and understandable documentation, including procedures, user manual, quality procedure, etc. Then the machine, and here I make quite a distinction between direct access, for instance, FTP, SFTP, scripting access, and web services and applications access that have very specific, fast evolving technology and jargon. And we must question also ourselves about which features we're talking for. We're talking for the use technologies. For instance, a widespread technology or standard increases the accessibility, interoperability, and reusability. About format, that would be for the dataset, or script file format and feed vocabulary. And for the web service and application, the use of web semantics, web metadata field name, and of course, the content itself. And then on which object of the system is FAIR principle applied. Objects such as, or assets such as datasets, services, web services, softwares, but can be libraries also, and procedures, metadata, vocabularies, web metadata, and technologies. Of course, all these objects, features, or entities are not distinct and are a lot interrelated. And to improve something such as fairness, the first thing we want to do is to perform an assessment of it. In the case of fairness, this is not an easy exercise. As I mentioned, in my opinion, all the systems should be taken into account. However, since the fair concept official description in March 2016, several assessment tools have been developed. And I won't do an overview of all the tools, but here I will present you a few tools that have been used and tested in the case of the EuroAgo ERIC. The first one was where the fair implementation profiles FIP and FIP wizard, which is a sort of questionnaires. This tool was best designed to assess fairness of technologies. This was used in the frame of the Fair project. And for us, it mainly showed that we missed a web-exposed vocabulary. As a sequel, there is also the semantic analyzer, which is developed by the BIODIS, that is best designed to assess the content of the metadata field and whether a match is found with some web-exposed vocabulary or not. We also used a OFAIR and Fuji tools. So these tools were mostly used to assess web metadata. Web metadata are metadata used to describe a web-exposed assets using web semantics. So it implies web-specific vocabulary with various standards. The first one, OFAIR, was tried during a workshop organized by the Fair Impact project, and the second one was used in the frame of the FAIRIS project. These two tools, OFAIR and Fuji, are two scoring tools. The main challenge of them, as I experienced so far, is that they are often difficult to understand. The results are difficult to interpret for humans without ever web IT specific knowledge or an advanced understanding of the tool. So they often lack of explicit explanations with human words regarding what is tested, what is missing, and why this may be of importance, together with quite an amount of jargon. The documentation is here, open access, of course, but the time to understand it can be lacking for some people. So last remark about this, they should be interpreted with care because some service can score low when from my point of view of data scientist, this is completely fine and fair because I clarify relevant documentation, clear instruction of what to do to access the data and no problem in getting the data sets themselves. But they score low because mainly web semantic is lacking, and as these two tools mainly test semantic web, this is why they score low. And on the overall end, they can score high because every tested feature is responding with a correct URL and URI, and so would sound okay from an automatic web application interfacing point of view, but as a human user, I could be unsatisfied, and it happens to me in some occasion that I went through some web exposed, I would say, data set, but I could never reach the data set itself in the end. So it's the reason why I'm presenting that. So that's why I say that the interpretation should be done with care and should account for the assumption of each tool, what they were designed for, what they test exactly, and why. So, sorry. Oh, sorry. Okay, click on the link. That's okay. Sorry about that. Excuse me. This is my last slide. As I mentioned, fairness was existing before the concept was created. And we've aimed at improving the fairness since the very beginning as a continuous effort, taking into account evolving technologies and habits. We are present some of the latest improvements we carried on. Two improvements that were direct application from fair implementation profile analysis, the use of a web-exposed vocabulary by switching from tables shared in open documentation to the NERC vocabulary server, NVS, of WODC. The creation of a Spark endpoint to search a Go platform ID and retrieve dataset from metadata fields. Spark being an SQL-like queries on the web. And we are continuously improving metadata. So here I'm speaking of metadata embedded in the dataset. I could take for a new feature and legacy issues. And currently there is an ongoing activity of improving the information transfer from manufacturer's metadata system to Argo metadata files for fields such as serial numbers or calibration coefficients. And we are also testing and using new technologies that are more analysis ready and cloud optimized, or as said, Argo, looking for more efficient ways to distribute the datasets to the user, such, for instance, the S3 bucket and the protocol associated, for instance. And lastly, I will mention that within the FERIS project, we are currently creating a web service for biogeochemical delayed mode processing to improve the fairness of the delayed mode procedures. So, as a conclusion, I would say that in my understanding, fairness is a multifaceted concept that is spread within all the system from upstream to downstream in several layers and many intertwined aspects. Tools to assess and improve are being developed. They are powerful, but need to be improved to ensure specific challenges such as easy human interpretation, especially non-expert in web technologies. In Argo case, we have been showing a few gaps which were or will be addressed. Fairness improvement is not solely guided by these tools, and other improvements are being carried on continuously on other aspects. Thank you for your attention. I want to acknowledge Jana Vaderoek, our EuroArgo Director General, which was also been initiating the slides. And following project such as Blue Cloud 2026. Thank you for the webinar. Fair Impact, FERIS, and Fair. Thank you very much.
Thank you very much, Delphine. Again, another very interesting presentation. And it's also good to mention that the collaboration with FERIS, the project that Delphine was mentioning, has been very recently officially formalized. And among the things where the teams are collaborating is exactly the work on shared best practices on fair data management. So exactly what Delphine was presenting, and EuroArgo is also one of the data providers that Blue Cloud is working with exactly to help the community improve the fairness of their methodologies for data managing and data gathering. There is a question for you, Delphine, before you go. From an EMSO Eric participant. Is the process of copying data to Sanoe automated, or is it done manually?
The monthly copies, is it? Yeah. I think it is automated, yes. Yeah. The archive is done automatically. Then the exposition of it on the Ciner web page, I think it is also automated. Yeah.
Thanks. And for all interested, so the slides will be available. So in case you need to further go back for our speakers, you can just contact us after the webinar. We'll be happy to put you in touch. So before moving to the, thanks a lot to Delphine, by the way. So before moving to our first speakers, in order to give you 2 minutes of comfort break, if you want to access this Slido and start looking at a few high-level questions that we have put there, you can scan the QR code or copy the link or use the code to log in to put the code on the main Slido page. While we move on with the other two presentations, we invite you to have a look at the few questions there and answer to them, since this will be then used for our question and answer time and discussion moment at the end of the presentation. So colleagues are also putting a link in the chat, so you can look at that. So I can call our next speakers is Joanna Bella from Blitz on stage.
No. Hi, everyone.
Joanna.
Yes, you can hear me now, right?
Yes.
So I can share my screen, Sarah, is that
yes?
Okay, cool. All right, so I hope you can all see it, because I can't.
Yes.
Good afternoon, everyone. I'm presenting the fairness of data within Eurobus and Emonet biology. So to start with, I would like to define a little bit what Eurobus and Emonet biology are. So Eurobus is the European node for the Ocean Biodiversity Information System. And for those of you that have heard the name Eurobus, you might also have heard it referred to as the data infrastructure behind Emonet biology. Eurobus is funded by LifeWatch. It's currently funded by LifeWatch, and it's an initiative that started in 2004. And Emonet biology is the EU service for in situ marine biodiversity data. And it's started in 2009. So these two initiatives, let's put it like that, they have a common data and metadata infrastructure and common data publication procedures. And because of this, let's say, a Siamese connection, it allows for the sharing of data with other international initiatives like OBIS and GBIF. For those of you that are not really working with with biological data, it's the Ocean Biodiversity Information System and the Global Biodiversity Information System. So how does that happen? Very briefly. So the any data that are published in Emonet biology are exported as well to the Eurobus IPT. I will explain afterwards what an IPT is. And this was true up until fairly recently. We have slightly adjusted our procedures. So basically what happens now is that you will find that if you search the data in Emonet biology and the data in this Eurobus IPT, you will see that there is a bit of a discrepancy. For example, we have more than 1,400 data sets published in Emonet biology, whereas in Eurobus there is only slightly over 1,100. And this is because we are, both OBIS and GBIF work as a federated network. Any organization, as I will say a bit later on, can host an IPT resource, and the principle is just to publish once and reuse many times. So instead of publishing all the data via the Eurobus IPT, we are harvesting data from other instances and ensuring that we make the most of this federated network and we don't contribute to any duplication in both OBIS and GBIF. And we also have, so another, what happens is that once the data are published in the Eurobus IPT, both OBIS and GBIF will harvest those resources as well. On the right-hand side of the screen, you can see the resources or the data sets, and they can also be found in those other two portals for those two initiatives. And one other, so this is something that happens without extra work. And due to the development of the EU data lake that Sarah has actually mentioned initially as well, a subset of the EMONet data are also available in the EU data lake. At the moment, this subset only includes the occurrence data and not other associated data. But I imagine that this will be further developed in the future, so there is exactly the same data available through this platform as well. Okay. So what happens? So the metadata records are also quite an important part of making the data findable and discoverable. And due to the standards that are used, they can be found in multiple catalogs. I have a list of those there, and the image is just a screenshot of the EMONet catalog for the biology metadata records. So again, I think this just highlights the importance of using standards that are well governed, because this does allow for the access of data and the information on those data, on the metadata for various stakeholders and across multiple platforms, initiatives, and so on. Okay, what is the IPT? The IPT is the acronym for Integrated Publishing Toolkit, and it's a software tool designed by and developed by GBIF that allows the creation and the share of data across the various data repositories or data providers. You see in the map just the number of installations for this tool. So it really shows the power of the federated network. I don't have the same image for OBIS, but that will be equally relevant as well. So OBIS, the OBIS approach is with regional nodes, of which EuroBIS is one, is the European node, and it has 7 thematic nodes. But alongside these, there are other IPT instances that can be on an organization level or on an initiative level that can also share data, and those data will be made available through these, through OBIS, through GBIF, and also through EMONet biology. I don't think I need to say anything else here. So now for the Blue Cloud 2026 plan. So this is the completed work that was done. So I can speak of EuroBIS metadata and EMONet biology a bit interchangeably at this point. So things that have been done was adding semantically interoperable terms from the BODC NERC vocabulary server to accommodate for the description of instruments and parameters. So on the right-hand side, you have a screenshot of the BODC collections. There are a number that are in use here at the metadata level, and I will also mention it a bit further on, but there are also a number of collections that we use on the data itself. So going back again to the work that has been done under the Blue Cloud to improve the fairness of the metadata records. So it was also the inclusion of the URIs to various metadata values. So you can see on the left-hand side that, for example, the white box just shows the front end of the metadata record. But then you have in JSON format, you have the URI for that acoustic telemetry term. And this is not seen by the user, but it's readable to the machine. So that is a quite good improvement that was done under this project. Also, the number of formats that can be used when exporting the metadata records. So initially we had only a few of these before the team working on the Blue Cloud project started doing this. So the work basically, I think what's important to say is that the work is not being done on the data management alone, as in adding more values and linking the vocabularies, control vocabularies, but there was also work done on the technical level. For example, as well, the DDAS endpoint that was created for the Eurobis collection, for the metadata collection. For the to-do plans, what's left to do at this point? So the plan is to also, well, as Delphine said, this the fairness is a ongoing objective, and we can always improve on the fairness. And at this point, I'm focusing on the metadata. So the aim is to improve that in the quantity of agents. Also, we have a number of keywords that we use that are developed in-house or hosted in-house. And what we want is also to add links to those keywords so that they are also machine resolvable and readable. In the taxonomy, we are going to separate the terms, and this is done via another project that we are involved in, but it all contributes to the same objective, which is to improve, to continuously improve the fairness of the metadata records in Eurobis and Emonet biology. And we also are looking into improvements of the DDAS output as well. And then we also have changes that are pushed via EMODnet itself. So the previous ones were very much along the work plan of the Blue Cloud project, but also EMODnet pushes for some of those changes. So as some of you might know, the EMODnet metadata, in which Emonet biology metadata is included, adheres to ISO 19115 and INSPIRE directive. And in the coming months, there will be a harmonization of various things within the metadata records for EMODnet. So we will initially focus on the distribution information, on the legal constraints section, and also on the citation field, so that our users can always find the information across all of the EMODnet thematic lots in a standardized way, in a harmonized way, and presented in the same way for everyone. This, again, is changes that are being pushed by EMODnet, but they also affect the Eurobis metadata because, as I've said in the beginning, they have the exact same system. In terms of the data, so our data adheres to the Darwin Core standard. This is something that the biological community uses. We initially in the ocean community, in the ocean biodiversity community, the taxa was described using the worms taxa. So it's a control vocabulary that allows for the taxonomic links and the locations of the samples or where the taxa were observed through the Marine Regions Gazetteer. And in 2017, there was the Extended Measurements of Facts, EMOF, extension was implemented, and this was done to improve the machine interoperability for other measurements or facts that were collected or sampled when the biological occurrences were also either observed or sampled. And the vocabularies that we use, again, as I've said before, are the BODC NERV vocabulary service. I only added a few of the collections that we use. So for parameters, for example, chemical or physical parameters, we use the P01 collection, or for biotic information on the taxa observed, we use the P01 collection. We use for the units, it's the P06 collection. For instruments, the L22, and for habitats, for example, it's the C35 collection. There are a few more that we use, but I didn't want to go on a very exhaustive list because I don't think it was really necessary here. So basically, the use of these vocabularies allows for an improvement of the interoperability, not only across the biological data sets, but also with other disciplines. Because, yeah, I guess if you work in physics or in chemistry, yeah, in the ocean, you will probably be aware that for that describing your parameters is essential so that you can compare data, you can merge data, and you can be reassured that you're using always the same parameters to describe the phenomenon that you're observing or that you want to do your research on. This is my last slide. I don't have anything else. I hope it was clear, although quite succinct. Thank you. I'll wait for your questions. Thank you very much.
Thanks a lot, Joanna. Yes, indeed, there is a lot that you are discussing within the many communities that are addressed, that were addressed by your presentation, and in general that collaborate under the AIMONet umbrella, and as well as the Blue Cloud ones, and working on interoperability is fundamental. So I don't see questions now. So I call on stage Justin Bach, the last speakers that we have today. So feel free to share your presentation, Justin.
Finding the right screen. Should be seeing a wiggly line up here.
Yes.
Yeah,
we can see your screen.
Okay, this is good. So I'm going to move the context and move the theme. So far this webinar, you've seen lots of work on the collection and publication of data given out to the community. I'm going to be showing some work which has been 4 years in the making, with results that are less than 2 weeks old, in the uptake and the impact section of this chain. I did a search for data value chains online, and there were many, and I chose this one because it's blue, because it's a blue code webinar, plus it kind of makes the point I'm trying to make. And the other element was, before this I was told I have to explicitly mention FAIR and include the word FAIR and how the work I'm going to show relates to FAIR. So this site here shows effectively the FAIR principles. The work I'm going to show directly relates to assigning unique identifiers to data. They're described with rich metadata, and they're identifiable as well. So it's all around the F in FAIR and some of the A in FAIR. So what am I going to show you? Should flip to the slides now. So I'm going to show you the work of Research Data Alliance working group, which is coming to an end. We're about to start a new one. And these results were first shown in Costa Rica at the RDA meeting 2 weeks ago. And I've adapted these slides for this audience to try and give kind of a really clear narrative that you can actually engage with. This is the work of 4 years. It started 4 years ago at the AGE full meeting. We formed an AGE working group. We've brought together the views of data centers, data citation authorities, people like Crossref, DataCite, data indexers, journals, which every kind of stakeholder from the data centers through to the journals have been consulted and brought together. And this is actually results of 4 years consultation with those groups. And we've been looking at the challenge in what are known as complex citations. So next slide. And kind of going back in time when we first started talking about FAIR in about 2018, the first project then looking at FAIR was called Enabling Fair Data Project. It was a COPDES Foundation funded piece of work, and it very much looked at how data are cited in journals, and it was very much concentrated on the findable and accessible. And this work actually builds on those concepts. I'm going to try in 15 minutes. It's going to be a bit of a whirlwind tour, but introduce the concept of complex citation, the problems we have and what we're trying to address with this work, and then the use cases that we've got around this. I think some of those map very neatly to everything we've seen so far, plus also other Blue Cloud use cases. I'm going to introduce the recommendations we've produced and kind of the workflow actors and what the process looks like and what we're proposing. And where we're at this work is we've got some recommendations which we now actually want to trial with real data, and there's an opportunity to participate in that, and then look at the next steps. So what is a complex citation? We want to enable the creators and contributors of data, digital objects, and also physical samples to receive credit when their data are cited. and also where you've got really complex sets of data. So if you've got, say, 1 million images, or you've got hundreds of thousands of granules, how do you cite a subset of those granules? So my research has used 1,000 of these granules from across 3 or 4 different type repositories. I want to cite that block transparently, which means you get transparent science, but then I also want to make sure that the credit goes back to the people that created that data. So we'll look at how you cite subsets of larger data. How one of the use cases got IPCC, so where you've got the data underneath the graph, how do you cite the subset of those? So the graphs in the IPCC which go to policymakers are clear, so you've got transparent papers for policy. You need attribution of credit. It's been one of the goals of having fair data for a long time, and I'm actually starting picking it up and trying to actually address that with this work. Citing across different types of data sets. One of the real challenges in this is in the knowledge graph. So where if you start thinking of kind of the tree of all the data that you cite and everything that underpins your research, and for indexes, it's very hard to actually compute metrics and KPIs of usage. So we actually need to compress that knowledge graph. We've done some work on that. We're trying to think about beyond academia, traceability, and also that transparency. So complex citation is trying to address a lot of problems, a lot of challenges that we've got in the data citation world. And we built it off 3 use cases. So the first use case is BODC. Translates very neatly to CDataNet because BODC is one of the CDataNet nodes. And we've got effectively, depending on which database you look at, there's over 100,000 granules in one of them. There's over 500,000 in another. User comes along, they take a couple of thousand of those to use that for research. How do they cite that? And how does BODC as a data center actually get metrics for the people that submitted that data to show that usage? The IPCC, so they produce the report for policymakers, and there needs to be more transparency, and they actually want to make the data underneath the graphs in the IPCC report transparent for users and readers and the audience. And then Ameriflux and FluxNet, which is effectively it's a flux network in the US, and it's more atmospheric, but they've got this many granules problem, and they're trying to cite subsets of the data. And these translate beautifully across to, I mean, you've seen Argo here. I think there's over 2 million profiles now. I'm probably wrong, 2 or 3 million profiles. But how do you accurately cite subsets of Argo data? Within Blue Cloud, we've also got CDataNet. It's also got millions of granules, so they translate very neatly to Blue Cloud use cases. So this is the workflow actors, and we've kind of designed a little bit of a workflow where you create. I'm just going to go to another screen, so I've got a bigger picture. So at the beginning, you've got effectively digital object creation. So when a researcher comes along, they want to create they're creating a paper, they want to get a single citation that the journals want to have for the data, so they don't have thousands of citations. They generate that citation, which can go across many different repositories. It can be subsets across different repositories. That citation goes, that citation block, or that complex citation goes along with the paper, which means in academic papers, you only need to have a single citation. This then goes to be indexed, and then you can actually get credit back to originators. Anyone reviewing the paper can get back to that data and actually see that research. Anyone who is reading that paper and wants to try and actually see what's happened in that paper can actually get back to it. So we've designed a new workflow around how you cite data in academic literature. That's the key thing for me. And we've defined a couple of new terms as well. And the names of these terms are kind of still in a bit of flux and open for input. But we've spent quite a lot of time going in circles trying to define these. So the first is a complex citation object. It's a new type of digital object identifier. It's supported by Crossref and DataCite, and it includes a list of linked digital objects. So effectively, it's a DOI, and within the DOI, you've got a list of different objects with those granules within those data sets that you're citing. So maybe 50 Argo profiles here, 200 CDataNet kind of granules here, some BODC granules there, and that's all in kind of a single identifier. And then linked digital object, so they're those entities within there, and also the metadata within those entities that actually make up that complex citation object. So it's effectively those granules within our complex citation object. So that's kind of the concept. Now we're going to kind of go through a set of principles we've defined and recommendations we've defined around those. There's a lot of words here, and I'm going to try and tackle each one at a time, give you an overview. at the beginning of the presentation, there's effectively a report which actually shows all those recommendations in detail. If you're curious, I recommend having a look at that. We've also got details on the use cases in there, and also a couple of kind of prototype complex citations we've created, so you can kind of see how it could work for you. But so, and the first set of recommendations, these are ones which we think must happen, and they're the ones they're critical. So the first is it must capture a sufficient level of granularity to ensure credit and provenance to the specific cited material. We want to give credit to those, so we actually need to get back to the creators of those data that are within that citation. The second is around enabling a mechanism of automatic attribution and credit for each individual object. So it must be indexable by cross-reference data site, and we must be able to get citation metrics from those. Must be clearly demarked object. This is not a primary output and should not accrue credit itself. We're conscious that the citation object is not its own piece of research. It's just a mechanism for describing the data in a paper. So it's not its own research object. So it doesn't accrue credit, and it's not like a data set effectively. It references data sets and the credit exists there, but the citation object itself won't accrue credit or any attribution. Each object must be identifiable, referenceable, stable, and resolvable through use of suitable PID mechanism. Within the work so far, we're looking at DOIs because we think DOIs are the current one that actually has the capability we need, but we know in future that we may need to go to different PIDs. It means you get the tombstones that you get with DOIs, for example. And it also gives that kind of long-term provenance, so you can always go back in time to understand what actually underpins a paper. So they're the must. The next set of recommendations are should. So we believe they're important, but they don't apply to all complex citation objects. You need to have a suitable versioning mechanism, so effectively where you've got data versions. You should adhere to a standardized structure, agnostic of any particular provider, because you want to have common tools and common approaches. So we actually want to have, so everybody doesn't have to build their own infrastructure to do this, which means we can then share code and share approaches across different groups. Each object should support the use of persistent identifiers for linked objects with complex citation where possible. That's effectively just reiterating what I said 2 slides ago. And it should be sufficiently flexible to allow easy adoption by providers of complex citation objects. So we want it to be easy for communities like Blue Cloud, Argo, CDataNet, BODC to be able to adopt. There needs to be a low barrier to entry, and any data suppliers need to be able to actually implement it in a ready way that doesn't take a lot of time. Last 2 recommendations also should. Complex citation should be provided such that its metadata and content are always open accessible. So this gives that long-term accessibility and that kind of traceability and transparency of any work. And it should have sufficient provenance and metadata for its creation. So we've developed within some of the prototypes a basic metadata model, and we're keen people have a look at that and feedback on that. So the 10 recommendations. It's a lot of material to give in 15 minutes. I appreciate it takes probably a read of the recommendations to actually address those. The slides didn't change, I've just worked through them. So the last slide I've got kind of go on to the next steps is, are we actually solving the problem? Is the work that we've got in the recommendations and the work that I've just kind of described to you actually going to solve any of the problems which I presented in the first slide? So the first is citing large number of data sets. We've looked at the approach and we've got some feedback and we believe it does. The second one is underpinning data for graphs. We believe we actually meet that criteria as well. Enabling credit, we do. We believe that needs to be worked through by the indexers. Citing a large group of data sets, we cover that criteria with this. Compression knowledge graph levels, we've actually got a model within our recommendations that shows how you can compress the knowledge graph levels to make it readily indexable to give KPIs and metrics. Use beyond academia, we've actually reviewed that with industry, and we believe that yes, we've actually read the criteria. Traceability, we believe we've met that. And then we've also got the knowledge graph limited to 2 levels. We actually have 2 approaches presented in the recommendations, and believe we can tackle that. So we've got a set of recommendations. I think they actually cross and meet the criteria for the problems we've set. And this is the bit that's quite exciting, is about how we engage further. So we've The recommendations are still open for feedback. They're on this DOI. If you have a look at the DOI, have a read if you're interested. We're keen to get feedback by the end of this week. We're also going to be presenting this work in a town hall session at the AGU full meeting next month. But we're open to feedback throughout this process. So yeah, if you're interested in this and really keen, please have a look, have a read, and get in touch with us. If you include Shelley Stool in the communication, she's actually leading the production of that document, along with any of the co-authors. We'll make sure we get that feedback in. And we're keen for people in this community to be part of the next phase. There'll be a new working group where we're actually going to look at how we implement it. So we're going to take those recommendations and test their feasibility. So we're looking for implementers and people to test that. And I think within Blue Cloud, there are many systems and components, OBIS, CDataNet, Argo, that are highly relevant and would be fantastic implementations, and it potentially something we could look at a task within Horizons Europe proposal. Just want to say thank you.
Thanks a lot, Justin. And indeed, we will distribute this further via our social media channels. But if you want to share a few lines as well, we're happy to distribute it via emails as well to the Blue Cloud community at large. So please do so. Okay, thanks. Our chat has been busy in the meantime, so we had a few questions replied. So happy to see the interest going on. And while we open now officially the question and answer moment, I also invite you again to join our Slido channel and connect there. And I'll soon pass the floor to our colleague Alicia for sharing some of the results. Are there any other questions in the meantime for our speakers? Anybody who wants to raise a hand, feel free to do so. Otherwise, also type your questions and we will look after them in a written format. Alicia, shall I give the screen? Shall I pass the screen to you?
Yes, thank you very much. I think I'm sharing my screen. Can you see? Yeah, Justin is saying yes.
Yes.
So thank you very much.
Now we can see
I see a Slido
it.
poll.
Yeah, thank you.
Just to say, whilst the Slido poll is running, that I actually first started work on citation probably about 12 or 13 years ago, whilst I was in Argo, trying to look at the citation challenge in Argo. And it's been a long road.
Okay, so I think it's the answer to this first question, what is the level of adoption of the FAIR principles, is as expected, I would say. So we are setting up this training activity, which we call training. We know that we don't have the ambition to, of course, give you a full training. We hope to introduce you to some techniques and methodologies. So half of you was already working with some of these practices. So good to know. We hope that you learn something new and that you can further implement them in your research. And you want to move on, Alicia? The second question, yes. So which aspects of the FAIR principles are most challenging to apply? We've mainly addressed interoperability today and reusability, I would say. We are all, I mean, Blue Cloud, but also Emonet and the EuroArgo, all the other projects you've heard about today are also addressing expandability and accessibility of the data. But the core of the presentations today, I think we're targeting more interoperability aspects, which looks like, I mean, according to your responses, still the most challenging topic. It's probably because it's the one that goes longer across the different phases. You never achieve interoperability once you've done one step. You need to go to the following one. Yeah, Justin.
It's a really interesting answer. The reason I say that is because when FAIR was first proposed in 2015, 2016, the first projects on FAIR only looked at findable and accessible. And there are a few brave people looking at interoperability. And I think as we've achieved findable and accessible, the community has now moved on to interoperable. So interoperable is the challenge at the moment because it's a thing we've reached in the adoption of FAIR. I think it's a what's the word? I think it's partially because of the way FAIR's been adopted and the priorities that came at the beginning versus the priorities now.
Yeah. Thanks. It might also be that data in this domain are already accessible, or the majority, yeah, which is a good sign. It depends, of course, a lot on domains as well. And the ocean and marine community has been active since ages, I would say. So the probably accessibility part has already been solved, or a lot of it. Okay, next slide. I would suggest Alicia, or which stage of the data value chain benefits most from the application of the FAIR principles? Yeah, it's a tricky one. We're not really, I mean, the users are not really addressing the stages of a value chain, but more probably calling for the aspects of need, FAIR practices, make upstream possible, yeah. Products, yeah. Yeah, also like a loop upstream. We're forced to use one word, I presume. We can probably move on, Alicia. What are the biggest challenges, difficulties in implementing the FAIR principles? Lack of skills, technical support, costs, probably is cost of human resources, I presume, and time consuming effort.
I can clarify and put that answer. So yeah, it costs a lot more in terms of time, systems development, sustainable. So to actually make data fair, because you're doing a lot of curation as part of that process. And speaking of someone who's moved roles recently to a different team at a different place in the kind of ocean value chain, I've actually moved to the observations level. There's a lot less money available at the data end of the chain than there is at the observations level.
I cannot see the slide anymore.
Yeah, I was changing the format so then you can see the words
Yeah.
better.
Okay. So and by the way, since I see these comments, I take the opportunity to point you to a project that was mentioned by Delphine before, which is the Fair Impact Project, which launched a series of open calls to provide support on adoption of fair enabling tools. And there is an open call still open until next week to get some money to dedicate human resources and efforts to join a series of support activities. So maybe since this is a need, and if you haven't heard of it already, you could have a look. I paste the website in the chat, and in the main web page, you'll see a link to these open calls. Maybe it's a good way to get some support. The application is really easy and short. Okay, so if you have enough an hour and a team that is geared to improve their practices, have a look. Human resources, yes. There is an entire EOSC project called Skills for EOSC, that is also implementing competence centers to provide support to data stewards, for instance, as well. Next slide. And what are the benefits of implementing FAIR principles? I have a question. Yes, I believe it's about the open calls. Associated countries can apply. So I'm not 100% sure. I presume you call for Nigeria, you can. But if you write an email, we can respond to you. And in the meantime, the benefits, the majority relates around efficiency. Yeah, harmonized products to inform policy, which is one of the impacts that open science and fair practices can can make easier, let's say, to achieve. Cost-effective data free usability. I think the benefits are clear. Yeah. More knowledge for better decisions. Transparency. Thanks. Do we have another? How many? One or two?
Yes, we have two more.
Two. So, in your opinion, to which objects among datasets, web exposition, metadata procedures, technologies, standards, format, content, and entities, human or machine, over data system shall the FAIR principles apply? Yeah, I like to see the first comment on software, because actually it is one of the key aspects that is being addressed these days for verification. So it's not just metadata is the core probably still, but yeah, sensors as well. There are teams working on physical infrastructures to ensure the data are fed by design from the moment where they are brought to the data managers. But okay. Since we are reaching the end, maybe we close with the last question. Are the fair principles a barrier to working with the industry? Looks no. But we should ask this to industry representatives, probably.
So I'm on an industry working group in the UK, and they have principles and concepts which map very closely to FAIR principles. It's actually the challenge with industry is more language and actually making sure you're speaking the same language, speak about the same principles and concepts. Once you've actually crossed that bridge, it's actually pretty easy.
Great. I think we've reached the time, so thank you all for staying so long. As I said, the materials will be shared on our website very soon. So sorry, I wanted to share the last slide, but it's simply to say that there is a training academy page on the website where you can see this and the materials from the previous event and stay in touch with any upcoming initiatives. Special thanks goes to the IEEE team and the OBPS team that facilitated the organization of this webinar, and Eurogoose team as well. So I think we can close for today. Thanks a lot to Lucy, Delphine, Joanna, and Justin, and all of you for attending. Thank you very much, and enjoy the rest of the day.